Find the x-coordinates of the 2 points on the curve with equation x cubed with the gradient 1. It can happen if this is the curve, there might be 2 points where the gradients are same. So we have to find if that gradient, suppose that is 1. So dy by dx here is 1 and dy by dx also is 1 here. So we have to find the point. We don't know what the point is. So we can do this. Let's start with the gradient. So dy by dx, so this is going to be 3x squared minus 11. So when dy by dx is 1, we know that the gradient is 1. Therefore, 3x squared minus 11 equals to 1. 3x squared equals to 11 plus 1 is 12. Therefore, x squared equals to 4. And we know x equals to plus minus square root of 4. That becomes plus minus 2. So we have two values of x. So one is x equals to 2 and one is x equals to minus 2. We have to find the corresponding values of y. So when x equals to 2, y equals to, remember this is dy by dx, this is y. So y equals to 2 cubed minus 11 into 2 plus 1, that's going to give us the y value. When x equals to minus 2, then y equals to minus 2 cubed minus 11 minus 2 plus 1, and that is going to give us another value of y. They didn't ask for the point as the answer, so we can either state the answer as x equals to 2, y equals to something, x equals to minus 2, y equals to also something. This is another sum similar to every other sum. So f prime x, usually we can get y equals to fx, but it's fine. So we have to find f prime x. So if fx equals to x plus 9x to the power minus 1, we take the x upstairs. So the derivative of fx is f prime x, which is derivative of x is 1 and this is 9. Derivative of x to the power minus 1 is minus x to the power minus 2, which gets 1 minus 9 by x squared. Now in question number B, we have to solve f prime x equals to 0. So f prime x equals to 0. Be careful, this is not inverse. This is f prime x. So therefore, f prime x stands for 1 minus 9 by x squared equals to 0. We can write 1 equals to 9 by x squared. We can cross multiply and write x squared equals to 9. Therefore, x equals to plus minus square root of 9, which is plus minus 3. In this particular question, the algebra is a bit difficult. Let's try this. First of all, let's start with simplifying the bracket. X to the power 3 by 2 minus 1. X to the power minus half plus 1. So when we simplify this, we have to use the indices simplification rule since we have powers here. So x to the power 3 by 2 into x to the power minus half. Then we have plus x to the power 3 by 2 into 1, which is going to give us x to the power 3 by 2. Then minus 1 into x to the power minus half. Then we have minus 1 into 1 is minus 1. Now we can write x to the power 3 by 2 minus 1. This rule is the indices rule. X to the power a into x to the power b is x to the power a plus b. So that means 3 by 2 minus half. This would be x to the power 3 by 2. This would be x to the power minus half. And this is minus 1. So 3 by 2 minus half is 3 by 2 is 1.5. Minus half is 0.5. 1.5 minus 0.5 is 1. So it's going to be only x. So x plus x to the power 3 by 2 minus x to the power minus half minus 1. Now in question number B, we have a curve which has this equation. So y equals to this. So let me write the simplified version. So y equals to x plus x to the power 3 by 2 minus x to the power minus half minus 1. Now let's differentiate this. So dy by dx, the derivative of y is dy by dx equals to derivative of x is 1 plus this would be 3 by 2 x to the power 3 by 2 minus 1 minus this would be minus half x to the power minus half minus 1 and constant is going to become 0. So 1 plus 3 by 2 x to the power 3 by 2 minus 1 is half. Minus into minus is plus. So minus half minus 1 is minus 3 by 2. Let's make the power positive. So 1 plus 3 by 2 x to the power half plus 1 by 2 x to the power 3 by 2. Now question number C. At x equals to 4, dy by dx, we have to find the gradient of the curve at the point x equals to 4. So all we have to do is plug in this value in this derivative. So dy by dx is 1 plus 3 by 2, so 4 to the power half plus 1 by 2, 4 to the power 3 by 2. Now the indices skill come in handy. So 1 plus 3 by 2, we know 4 is 2 squared, and when we have a power over a power, the power is multiplied, plus 1 by 2, 4 to the power 3 by 2 is 4 squared into 3 by 2. We can write 1 plus 3 by 2 into 2, this 2 and this 2 cancels, plus 1 by 2. Now here we have 2 to the power 2 into 3 by 2. This 2 and this 2 cancels. 2 cube is 8. So we can write 1 plus 3. This 2 and this 2 cancels. Plus 1 by 16. So this is 4 plus 1 by 16. So this is 65 by 16.